good afternoon, everyone. It's great to be here. I think I've been, as Dr. Vivek had mentioned, I've been here for a few occasions, and all I can say is every year over year, this event really gets better and better. So I'd like to congratulate the organizers and also thank the organizers again, Dr. Anil, Dr. Vivek, and others, for giving me an opportunity to, share some thoughts on this particular topic, right, especially on solar power. Just a brief about myself. I have been in the R&D for the electrical power area for over 25 years now. I did my PhD in the US in the electrical power grid related area. So I started my career as a transmission planner, so exactly addressing some of the aspects that Mr. Anil was talking about. But at that time, we didn't have to worry about renewables and all that. It was more how to handle the grid power flows, the short circuits, and the stability associated with new generators coming up, as well as the loads that were increasing. Subsequently, this was in the US. And then in India, I was working with GE for a number of years, primarily developing the technologies in the electrical power area, all related to renewables and smart grid. So that was when got introduced a lot to the understanding of how the renewables would make an impact on the grid, especially be it wind or be it solar, and how the transformation of digitization is really helping, or transforming, right? I mean, the whole area in there. And for the last 2 years, I've been with Luminous Power, and as many of you may know, Luminous is primarily in the area of power backup inverters, energy storage, and solar solutions, right? And so now I'm coming all the way to directly to homes, right? And really seeing what kind of a system can really help, get a 24/7 power with solar. So the topic that I selected was the solar opportunities for prosumer applications in this area, right? So I think we've covered quite a bit of discussion over the last couple of days, right, on the transformation that's happening in the electrical power industry, right? I mean, traditionally, well, everything was a one way from generation to transmission to distribution and loads. Now we are talking about not only the complexities of the solar and wind renewables that have been coming up for the last, I would say, a couple of decades, right? First it was wind, and then kind of solar took off, and now we are seeing electric vehicles coming in, right? So the grid is going through a very, very dramatic and unprecedented transformation, right? In both from a technical perspective as well as from operational perspective, right? Now, in terms of where we stand in there, right? We do see that the energy and demand has doubled, right? I mean, increasing in population and income, especially since 2000, and we still have a lot of opportunity to grow in India, right? While we have made tremendous progress over the last couple of decades, and as I think we also had our earlier in the earlier session, we said. Early 2000s, we were saying, so many thousands of villages. I mean, over 150,000 villages now unelectrified and all that. And now we are in a situation where, the grid is going through all these places, even though it's not a 24/7, supply yet. But that's what we are all, trying to drive against. And we see solar is the fastest growing among renewables, right? I mean, this is, first is we're getting into a state where, the growth of solar has been happening a lot in the, I would say more in the utility sector. And then, of course, the C&I sector has come up on the rooftop side of things. Residential, I would say it's still a slower progress. There's a tremendous opportunity there. So it's an area which is, kind of ready to explode in India from an opportunity perspective, right? And we are seeing a growth, but this growth is going to increase tremendously at residential and small commercial levels as well, right? So today, India's overall solar installations is about 58,000 megawatts, right? And we all talked about the opportunity to get to the 300,000 megawatts by 2030. So that's a very ambitious and good target. But I'm, quite confident with the way things are evolving that we should definitely drive towards that. The rooftop solar is still a slower growth. We were expecting more, around 40,000 megawatts by the end of 2022. That was our plan. But now we are looking at more, I mean, as of today, at least in some of the reports suggest it's close to 8,000 megawatts. So there is tremendous opportunity there. And even within, if you kind of cut down this 8,000 megawatts too, right? I mean, the residential portion will be very, very limited. A lot of these are primarily in the commercial and industrial segments. There was also a study that was done, I think maybe a year and a half ago. This was by Niti Aayog with Rockefeller Foundation on benchmarking Indian utilities. And when they went and surveyed different places of electrification as to how well things have been progressing, they found that 87% have access to grid-based electricity, and the hours of supply were only about 17 hours per day. That means there are still several places in India where there is significant kind of outages, and those obviously have to be addressed if we have to get into 24/7. Right? And the key drivers for end consumers is primarily on reduction in cost and reliability of electricity, right? And now the whole ecosystem is transforming from a system and a grid centric perspective to a consumer centric perspective now, right? Or now we are, once you have solar in there, we call them as, now we are calling them as prosumers, because they have the opportunity to generate power and also inject to the grid there. So the key drivers, why this, I mean, things have gotten into, driving on solar, especially in a prosumer world. The demands of consumers are increasing significantly, right? And especially after a COVID scenario that we've seen, a lot of people are now been working from homes. They need continuous power. They need uninterrupted power. And the demand, the people are buying appliances, so the loads in homes are also increasing, right? And environmental awareness is also growing across people, right? And people are now realizing the value of having more green power or renewable power and all that. So the education, to customers are also kind of evolving. Now the grid, as I mentioned, has already become complex, and weak distribution infrastructure, right? I mean, we all know, both from a financial perspective and a technical perspective, our distribution grids are not very strong, and that's one of the reasons why consumers are facing significant, outages as well. On the other hand, the solar panel battery costs have come down, the efficiencies have increased. We've heard this in the last couple of days. And so if I'm the end consumer, right, just looking at the option of electricity, I mean, today I have, solar and battery system can be a very good value proposition for me, right? Technology-wise, power electronics and controls are extremely important, because solar, you get DC, you need an inverter to convert that into AC. Again, a lot of technology development has taken place right from the device or component level, the power electronic devices, all the way till the systems and controls, the topologies and the controls that are required to make that electronics, convert into AC. What used to be, we developed as a square wave inverter, and as all, now transformed into pure sine wave inverters. So you get pretty much the same, sine wave electricity that you get from a grid there. So there's been a lot of technologies that have, the technology development has taken place. And overall, we all have seen also the cost of electricity now from solar and distributed power is becoming more and more competitive to grid power as well. So what will enable more drive, right? I mean, in this area is primarily faster payback period for consumers, right? And now it's becoming more and more feasible as we drive things forward there. Financing is very important, and I think this is where I would say, there is a lot of opportunity to drive and develop across, and we discussed quite a bit earlier in the earlier sessions as well. But this can be a real turning point, right, in terms of how consumers can start adopting this and become prosumers, right? And we also talked about the net metering policy, right, being able to have a way where any excess solar power that might be there can get compensated or use a net metering, and or be able to send power back to the grid. And one of the recent ones that also are evolving is on the drone policy, where you can take a drone out and go around and really survey the rooftops and really see where the opportunities are, how much of solar is possible, what should be the installation aspects in there. So it will helping both from an installation side of things and also in terms of once it's installed, right? I mean, in terms of what the servicing and all that is needed, right, for these kind of systems. So this can really transform too, right? I mean, in terms of how fast things can get. This transformation or this change can happen. In terms of applications, if you really look at across our country, we have places which are rural where there is either no grid power or very little grid power, right? Very high power cut, deficient areas. You have areas for semi-urban, urban areas where you can say almost like less than 2 hours of power cut in there, right? Of outages in there. And then the opportunities in commercial industrial as well, right, where you're using a diesel generator as a backup today. And with the upcoming technologies, there is absolutely no reason for us to continue with diesel. And with solar storage can become very, very effective, right? And so as a consumer now, there is an opportunity that they can have their own control over their system. Now coming to some technologies and I would say terminologies, right? I mean, there are several aspects for this on the solar system configurations for homes. One, what we call as a grid tie inverter, which I think we also talked about this morning, right? Where you have a solar panel and you just have an inverter and you just connect it to the grid. And this is basically where all the solar that gets generated goes into the grid, and obviously after taking care of the loads that you have in the system. This is good in areas, if you are not so much keen on power cuts, outages and all that, you anyway have solar and you can leverage that significantly. But then if you end up having be prepared for outages, right, in these kind of scenarios, then you would need a storage as well, right? Because then you would need for the solar to work as well. Otherwise, the solar can get disconnected as well. So then you would have what we call as a power conditioning unit, PCUs, right, where you have both battery as well as along with the inverter, which is kind of a hybrid thing, which has both connections from solar as well as the grid and the battery. Now, there's also advanced controls, and now we are calling it, terminology is called as hybrid inverters, which is coming up very much in there, where any excess solar power that you have, there's one inverter that can actually have the required controls that can get power back into the grid. And of course, DC grid is another option where if you have all the appliances all DC, then you can have a solar with all DC systems in there, right? So technical considerations, we talked about solar panels in the morning as well. There were multiple options there. Poly. Now it's all mono PERC, in there. Thin film is also evaluated with SIGs and cadmium telluride and all that. So new concepts are evolving, right, in there, and new power ranges are evolving. I think the power in the morning we talked about, I think 600 watt, hot panel and all that. So you need to have the inverters also adapt, to handle those kind of systems as well, right? And there you're looking at be it hybrid inverters, which I just talked about. There's also concept of micro inverters, which you integrate just with the panel, to get electricity. And then there is a high frequency type inverters that are used in the international markets more, where you don't need they won't use a transformer inside. It's all power electronics, and you develop a high frequency system in there. And now we are talking on grid forming inverters, where you're not only leveraging the inverters to help with your loads in your homes and loads that you have there, but also help the grid, right? If there's a challenge in the grid, can you have the controls that can really help the grid in terms of voltages and so forth. Storage, there's a lot of developments that are happening, especially in lithium ion. And you see, lithium ion is used in several occasions. I've seen that people use it as a generic term as lithium ion. But within lithium ion, there are different chemistries, right? The ones that are used in cars, primarily they were NMC, nickel, manganese, cobalt type of chemistry. And now they are transforming that into LFP, lithium ion phosphate kind of technology. And what we see for stationary applications, lithium ion phosphate technology is more relevant for the specific applications that you're looking at. And the battery management system in lithium ion becomes very critical, right? And that's why as this technology progresses, the controls associated with handling your battery, right, ensuring that the temperature doesn't go up beyond a certain value, becomes extremely important. So safety is critical there, right? And so you need to have the right kind of battery management system in there. And besides this, of course, the protection systems that we talked about are very critical, and especially when you're taking it into homes, right, rural areas or semi-urban areas, right? How educated are the installers from a safety perspective? Are we doing the right kind of earthing in the system? Because you're talking about DC, voltages coming up, right, from these panels, and you need to make sure that you have the right kind of protection systems in all these systems. They're very critical, right? Now, integrated systems controls are very important because you're having, you want to extract the most out of your solar panel, right? So there are different controls, pulse width modulation, maximum power point tracker, and also looking at smart load management, if you're able to handle the loads also accordingly together, right? So there are tremendous opportunities for technologists to really make an impact in this space and really drive the adoption of these systems in homes. And besides this, now we are also talking about connected inverters, right? Where you have, it's a smart inverter, right? You can go ahead and get all the data in terms of what is happening to the inverters, to the loads, to the battery and all remotely, right? And what's coming from the panel and all that. So remotely analyzing and really, ensuring that the system is working very fine there, right? So it's very critical that since these are evolving right now, it's very important that the Bureau of Indian Standards certification is extremely important to ensure that the quality of these products and solutions are met, right? Because you will end up having many new players, many people getting into this area and spreading across the country, right? So this is very important to ensure the quality in there. So, and we need to accelerate the progress. So here's where I would think the distribution utilities have to repurpose their business, right? I mean, in the past, everyone is a consumer. The consumers were purely dependent on discoms, and you go ahead and it's like it used to be like a monopoly, right? I mean, the wires are there, I own them, and I go ahead and provide electricity to them. But going forward, it's not going to be the case anymore. I mean, the consumers have, they'll have their solar panels, right? So then what would distribution utilities do? What is their business, right? How will they evolve, transform themselves, right? It's a big area of I would say, opportunity and discussion as well, right? And here's where government, utilities, technology providers, consumers, they all have to work together. Consumers have to be in the center of these things, right? I mean, to really drive this faster, right? And the policies also have to be very consumer-centric. While we all talk about, what should happen to the grid and all this, right? But what's in it for the end consumer, right? How they can, get the best value out of this. And then we talked about the financing models that will always exist, and technology and innovation will play a key role there, right? India, we are the leader in clean energy transformation. If you see the way we have evolved over the last 20 years, right? And last 10 years has been extremely significant, right? So this is the perfect opportunity for all people to, especially if you see any technology-related people as well, right? I mean, to really leapfrog with distributed energy solutions, right? And so that then we are getting into a 24/7 power. Finally, if you want to take it even further out, right, there is a lot of opportunity that is evolving in the global scenario where virtual utility concepts are emerging, right? So that you get into a state where if I have storage in my home and solar in my home and I'm not using enough for serving my loads, can I actually use transactive energy? Can I sell that energy to somebody else? Can I participate in some markets in there, right? So these are all the future, right? I mean, where things are headed. But again, the timing is right for us to really all push together and drive this transition. So that's kind of what I had for today. I'll be happy to answer any questions that you may have.